Hello guys, in this video I'll be introducing integration by parts. Okay, integration by parts is basically the integral of the product of two functions, each of which we could integrate. Okay, and this is the formula for integration by parts. So it's the integral of the function u multiplied by the derivative of function v with respect to x, and that's equal to u multiplied by v, take away the integral of v multiplied by the derivative of u. Okay, let's do a simple example. So if there was a question saying find the integral of 2x multiplied by e to the x. Okay. You can see that there's two functions being multiplied. There's a product of two functions. The first function is 2x, the other function is the e to the x. So what we need to do is split them and put it in this form. Okay. So it is very important what we choose as what function u should be and what function the derivative of v should be. Okay, so I was demonstrating that why is very important. For example, we say u is equal to e to the x, and the derivative of v is equal to 2x. Okay, so what we need to do is differentiate that, which is e to the x, and then integrate 2x, which should give you x squared. Now, if we substitute these into this equation, okay, just put the camera a bit down so I can get more space, we will get the following: e to the x, 2x is equal to u multiplied by v, which is e to the x multiplied by v, x squared minus the integral of v multiplied by the derivative of u, which is e to the x again. So you can see that we get another integral where there's two functions being multiplied together. So we would have to do integration by parts again. Okay. But if we chose u equal to 2x, what you would find out is if you differentiate that, you would get just 2, right? So instead of x squared over there would be 2. Okay, so it would be an easier integral. We wouldn't have to do an integration by parts again. So let me just quickly show that. So basically, when you choose what u must be equal to, you should choose the function where when you differentiate it, the x will disappear. Okay, so u equals to 2x, v equals to e to the x, dv over dx is equal to e to the x. And when you differentiate u, you get 2. When you integrate this, you get v equals e to the x. Okay, and if we now substitute this into the formula, we'll get the integral of 2x multiplied by e to the x, and that's equal to u multiplied by v, which is 2x multiplied by e to the x. Take away the integral of v multiplied by du over dx, which is e to the x multiplied by 2. We can put the 2 there. Oops, there's a dx I forgot as well. Okay. So if you see, we don't have to do integration by parts. We can just do normal integration now, which is a lot more easier. Okay. So let's just multiply that out. I mean, integrate it now, so we can get the result. Plus c, and that's equal to, if we take the 2 e to the x outside, you'll get x minus 1 . Okay, and that's integration by parts. So the key thing you need to remember when doing integration by parts, well, first of all, you need to say to yourself, is there two functions being multiplied together? If there is, like in this form, then you should be doing integration by parts. And the second thing you need to say to yourself, which function, if I differentiate, the x will disappear. Whichever one it is, then u should be equal to that function, because it makes things a lot more easier, as I demonstrated. So I hope this gave you some idea. If I did do a mistake, if I said something incorrectly, do tell me, so I can correct it by putting a maybe text message or something, or maybe redo the video. But okay, thank you. See you in the upcoming videos.